So let's start with Stefan. That's definitely one of the safe thing here. So Stefan is our principal backend engineer, and why we decide to open the conference with his talk is because he's purely traditional developer. And if you know Stefan, you probably know, and you probably think that he's one of the most traditional person you ever met. So he will talk about technical things, which is like our chance to, I mean, not the chance, it's our idea to actually celebrate the original idea of the TX conference with his talk. And also, I guess your guys fresh now to, talk and listen about technical topics. So I think it's a good time to start with that. So Stefan, you can join me on stage. And your talk can begin. Good luck.
I thought AI will do it for me, but so what happens with AI if there is no internet? Nothing. Okay. Oh, it's not funny. Okay. So thanks, Milica. Um, when I first started like thinking about this presentation, I thought about how to start, and then I saw this picture, and I had in mind this quote of Dan Rather, this the American journalist, like if all difficulties were known at the outset of a long journey, most of us would probably never start. So welcome to the session Monolith to Microservices, and as stated, I'm Stefan. I come from Doodle, and Doodle is the global scheduling leader that helps people to maximally use their time. And I often like to state that time is the only resource we cannot get back. We cannot buy it. So our platform helps our users to own their time and to find the mutual the path to mutual availability for the term either meeting with one individual people or a group of people. So with our platform, you save up to 45 minutes a week, you do much less, and you take your scheduling to the next level. So in the platform, we have 65 million of users, 32 microservices, and one monolith. So at the beginning, but yeah, that's about our tech stack. Our tech stack is that we use Spring Boot for the backend services, Kafka, Postgres as one database, MongoDB Atlas as another database, Keycloak, and everything is of course deployed to Kubernetes. Well, what about AI? You're probably asking, as we thought. Well, what about it? Um, each and every day, we probably oftenly see a lot of buzzwords on the social networks, on the media, on television, etc. And I often like to state when the AI does my laundry, then please call me. Like if everything is ready, then until that, well, I will think about it. But also, yeah, for this story, no AI. Well, probably because AI could not face all of the difficulties that we've been to. But maybe we'll talk about it later. So at the beginning, let's start. Uh, there was only monolith at the first point of our platform, and it was like this. So we had monolith, it had connection with MongoDB Atlas, and everything was working. It's really like working properly and give the value to the business. So that was nice, but it's our platform kindly and timely looked like spaghetti because of a lot of backend and frontend services were relying on the monolith. So each and every call was triggered there to get some data, show some data to the users, and it's like very interesting to decouple everything. So in order to how our platform was evolving during the time, since we started using Kafka, all other backend services needed to be updated with the data that was on the monolith, right? So the monolith. sorry. So the monolith needed to be reflected on the data that was updated on him. And he published up to some specific events to some topic events on Kafka. And then we had another services that was listening to all those events, get the data from the database.
Test.
Okay, I will do it like this. No, no.
Oh, I don't think. Sorry.
Yeah. So prepare the data and publish the data to the state topic. So you see these terms, events, and state. These are the topic types on Kafka. And what does that mean? That means like
Test.
Thank you. So how long the Kafka will retain messages by its time, and you can have it like by setting up the certain properties of the cleanup policy and attention time. What does this mean? This means that you are stating to Kafka how long some of the messages will be persisted on the Kafka disk. Like for the state topics, we often started it in indefinite or some huge amount of time, like 10 years or indefinite. But for the event topics, often the default value is 14 days, because you don't want your disk to blow up with a lot of messages if you have them on your platform. But then at some point, like, we introduce Keycloak, and Keycloak is the identity access management. And some of the key functionalities of the Keycloak are that authorization server, which was very important for us because all the authorization is executed with help of Keycloak. It has the support for OIDC, SAML, and OAuth too. It has its own session management. It has the user management, which was the most important thing for us. I am saying like most important, but everything is important for us. It has identity federation, so it's really easy to integrate any kind of identity providers that is OAuth, OIDC compliable. And of course, like there are more functionalities like MFA, customizable UI, and the most important thing for us is the extensibility. So the implementation of the Keycloak allowed us to have our own implementation besides the specific implementation of Keycloak. Therefore, we were able like to hook to the implement custom things that were necessary for our platform. So platform looked like this. Keycloak was deployed alongside the monolith, and it is using the Postgres as a persistent database and InfiniSpan for cache. So it looked like this. Then we thought about like, okay, well, what about our front end clients? Let's migrate them to Keycloak, and that was the great idea. But then what about the users? So we thought about, well, if there are no users, the front-end clients will not be migrated, but users also needed to be migrated. So at that point, we extend the Keycloak by implementing the specific consumers and specific producers, because we also wanted like to produce some data from Keycloak to Kafka to some other new topics that we introduced. So we connected the consumers to the state topic, and we produced the output of the data to some output topics. And yeah, when we first started this migration and deployed the Keycloak, this was very slow. And during that point, we had a lot of like pressure for other teams because they were relying on us. They were like constantly asking when the Keycloak would be deployed, because they were blocked by the Keycloak, because they needed like the functionalities of Keycloak in order to deploy their abilities that was already planned. And you can probably imagine from management to product, and everybody was a little bit of stressed at that point. But in order not to fall down, you remember this probably, we implemented a new help service, and we started migration, and we used the power of batching. So we used the power of batching both on Kafka and a database, and this kind of a migration was very fast. Like with Keycloak, this migration will probably lasted for, I don't know, 5-6 months, and we did it here for 2.5 days. So migration was done. At that point, was there any downtime? Well, there was zero downtime, and Kafka is really like helping you to achieve that without influencing to the end customers. But a monolith was still alive and operating. So architecture looked like this. We still had the front end clients. They were like connected with a monolith, so authorization was there. And in order to synchronize both of the system, monolith and keycloak, because nowadays you can go into keycloak, have your customer support have keycloak, and execute some of the updates on some of the entities or the users here specifically. But we needed to inform monolith that the change was happened, so that the monolith will publish again the state topic. But here you probably see the circuits. So keycloak, monolith, state topic, then again keycloak. But we did a circuit breaker on keycloak when each and every message is consumed from the state topic. No HTTP calls were executed. But we still wanted to ditch this red arrow, right? Because we haven't reached the goal, and the monolith was still operating. So we moved to the next steps. We now finally were able to migrate front-end clients to keycloak, and that took some time. We also wanted to migrate all possible user updates to keycloak actions. User updates like change passwords, update username, and etc. So at the end, like this was the connection. We still had the front-end clients that were executing some of the specific user updates on our platform that was not able to be migrated to keycloak, and those keycloak actions were transformed from the front end to keycloak alongside with the authorization. But not all possible features could be migrated to keycloak. Therefore, it gave us the idea to get this connection ditched. And because of that, we introduced a new service that handles these user interaction and publishing to Kafka, because we need to make sure that everything that is executed on our platform is reflected to Kafka. So yeah, all changes needed to be reflected, and we make sure that any interaction is published to Kafka topic. Therefore, we introduced that new service, but we wanted to create some kind of as much of a bulletproof solution that we can. And we ask ourselves how to achieve that, and we thought about it. So we considered the outbox pattern. We also considered transactions both on Kafka and JPA. But then in the end, we chose the outbox pattern for this specific situation. So we needed to watch on distributed environment because everything is deployed on Kubernetes. It's not one pod, it's multiple pods. And we help from Spring, of course. We were investigating the transaction listeners, Kafka transactions, and Schedlock. We also had the experience with Schedlock by executing some of the specific tasks in distributed environment, because only one pod can execute some amount of work at that point. Also, we started to think about it, started to think about some problems, and then problems, right? And one of the problems is how to get the data from keycloak to Kafka. And did we try to do that? Well, yeah, we tried to do it with multiple approaches. We tried to publish the data from Kafka to keycloak, and keycloak attributes gave us a big headache. What are the keycloak attributes? The keycloak attributes is something like a hash map, which allows any of the client of keycloak to add the specific data to this table. So either it's a single value or multi-value, you can add whatever you want. But then if the updates are triggered on this table, keycloak will first delete the attributes and then insert them again. So no update actions here. And it was really annoying for us. So we tried to use Hibernate because keycloak is using the Hibernate. Trying to use Hibernate to publish those messages. We also tried to hook up to Hibernate Anvers to do this options and functionalities, but at the end we had no luck. So then at that point, it was the time to make cutting down decisions. But at this point, we received a phone call. We received a phone call from product and from managers, stating okay, where we are, this project is already lasting too long. You told us everything was planned and etc. But we stated like, okay, we are near end. And a couple of days later, we introduced the CDC, or change data capture. So we introduced the Debezium. We introduced the Debezium alongside with Kafka Connect and Kafka Stream. Uh, Therefore, all of the data that is published inside the Keycloak is landing on the database. The Debezium is looking at the write ahead log, getting all the data out and publishing to the Kafka topics, specific Kafka topics. So one table in the database and one Kafka topic there for the Debezium and Kafka Connect. Because of that, because of all these actions were triggered on Keycloak, we need to make sure that we maintain the order of the actions. And when you have multiple topics on Kafka, it's a little bit difficult to summarize them all because you don't have the order. The order is on all of these different topics. And we wanted to be sure to maintain these order of the messages, and therefore we moved like to the ability to have multiple arrow schemas per one topic. If you don't know what are arrow schemas, they're technically the definitions of the messages that you can send to a specific topic. So it's basically some kind of a contract for the topic. And this provided us smooth processing. So right now we had on one specific Kafka partition, we had all of the actions like first insert or create and update and delete, and everything was in order. Because if we don't have the order, then everything will be messed up in our platform later on. So 3 months later, everything was near end, but then the QA principal interacted, and he stated like, I need to make sure that everything's okay. And we were like, but at this point, the QA principal, which is somewhere among us, he wanted like to be sure that since we are using Outbox and we are publishing all the data, and we get all the data from Monolith and from Keycloak and for other services, he stated like, yeah, I wanted to make sure that everything that I submit to these services is on Kafka in the correct order. And in this point, we had the error rate of 2%. So 2% of messages were not landing in the order that we have wanted, which was bad. So we did some load tests. Those load tests stated up those percentage, but so we did load test, of course, and they help us to minimize the errors. So from 2% of the errors, we went down to 0.2. So we introduced the retriable topic and retry mechanism a couple of times when we were consuming those data that come from the Debezium and Kafka Stream. So at this point, we were finally here. We were finally at the end, and technically our platform looked like this. So Monolith was really now totally on the left side. And we had like Debezium with Kafka Connect is connected with the Postgres database. As stated, they read the write ahead log. They publish the data to multiple topics, right? And then we had another stream service that was listening to all those topics, streaming everything and publishing to the one topic that had multiple Java schemas. So after that was done, that was consumed by the new service, and the new service like published the data to the state topic. And great. So at the end, we had some conclusions, of course. One of the conclusions is make decisions as soon as possible and be open like to change these decisions as soon as possible. Why am I stating this? Because all the way along we knew about the Debezium, but nobody had experience with it, and we were like a little bit afraid to introduce some of the new technologies that we might be face so much difficulties with it. We don't know how to handle it, and the time was like a specific resource for us at this point. But really at the end, like you should try out some things and yeah, try it, and it will be probably fun. Some of the other conclusions is that Monolith are also not bad, especially for the beginning of some businesses. You can have Monolith at the beginning, and while your business grows, then you can introduce mini monoliths inside the monolith and extract those monoliths and have them separately and scalable. So there is a project from Spring, like Spring Monolith, that really helps you build such kind of a monolith, such kind of a services, and it's very interesting and good. Also, try to start load test implementation as soon as possible, right? And try to have as less errors as possible, of course. And regardless of how you plan, additional work will always arise. During also this story, we had so much third party stuff and things that we have stumbled upon that we were not aware, even though the planning was like really great and we knew all of the details, but each and every time it's like, oh, we need to change this service and this service because it's relying on this data and etc. So the next conclusion is also negotiate for more time, like try to persuade the product people and the management like that you need a little bit of more time, especially because of the previous conclusion, and try to explain the product people what, why, when, and how, because we often got into a situation where the product people was asking us, but why do we need to have this thing right now? Can we like really deploy everything and have it? Why do we need to do? Because we need to deliver new features and everything, because all of these things are not delivering the new features to our customers, but it's helping us to decrease the tech debt and really like fastly then introduce new features when the time comes. And of course, at the end, you try to have fun. Yeah, and it's really like interesting. You went into difficult problems, difficult situations, and those things for us programmers is always interesting, right? Also, like try to have more time for the AI, if possible, of course, if there is an internet connection. And yeah, that's it. So thank you. And the battery is unchanged, right? So
It's a Q&A session. So, yeah. Test. Okay. It's a Q&A session. So, do you have any questions? I know there are a lot of product managers and QA principals here.
Why didn't the QA why you weren't included from the start?
I'm not.
Test.
yeah.
Why QA wasn't involved from the start?
He was, but the difficult thing for us is that part he needed to work on other things at the same time. So he technically did not have time to any do the load test. At the end, it was a couple of developers that did the load tests. But he was monitoring this story because he went into some other things. Also, the team had a QA that was testing everything in each and every change, and it was like when you don't have an integration test, you need to do the regression each and every time when something was changed, especially like how thorough they are in their work. So
Thank you.
yeah, thank you.
Anybody else? Okay, the principal.
Hey, Petko, long time no see.
Hi, Milos.
Can you please tell us why we even started migrating to microservices? What are like the cons and pros of each of the architecture types? Just in short, not
Yeah. So when you get a lot of traffic to some of the services, you don't want to overwhelm the monolith itself. Therefore, you extract that specific domain into specific service where you can scale, especially when you use Kubernetes. It's easy. But it's also like depending on the organization of the company, how many teams you have, how many people you have, who is the order, because as much of the people you have on the monolith architecture, it's a little bit of tidy, like about Conway's law and everything. So this was the motivation, like the traffic arose and we had more and more developers that were working on the new features. And we also had some of the technical depths on the monolith because the code is, let's say, interesting, and it used some of the other versions of Java.
But should a startup use microservices from the beginning?
No, no, no. I will stay as I stated for some of the conclusions. If it's as a startup, try with Monolith because you ain't gonna pay for this. So when you extract to those services, yeah, you need to pay for something. There, how it's stated, like there isn't such a thing as a free lunch. So it's also here. Because when you scale, you have another expenses. You have expenses for database, for pods, and it's we've been into this situation where we had a lot of bills for the database, and it was very interesting when people were asking why do we have so much of the bill. So yes, start with Monolith, but create that service as you are building the microservices. So try to have everything decoupled as much as possible. Try to have separate domains. And technically, this project from Spring would lead you to it. So technically, it will help you like create modulates, those mini modules, and then you extract the module into sub-services, which should be very easy.
Thank you.
Thank you.
Do we have more questions?
So is it like true if the people don't have so much of the questions that it was
Yeah.
not interesting?
But just a remark, there is a free lunch here today, so.
Ah.
Okay.
So there is a free lunch.
Okay, I have a question.
Yes.
So I'm not a technical person, but from psychological point of view, can you share a little bit more about the team dynamic during the whole process? Because I can imagine it was, tense at a moment.
Yeah, it's often like that. Like we also had from time to time we had some of the discussions inside the team, which took a lot of other people's time, and they were like, why are we like talking about why are we using these kind of things? But we were challenging ourselves, and we wanted to make sure that we have the best possible solution. But yeah, it's always not like pleasant when you plan everything and you started like big, and we had a good plan at the beginning, but then in the meantime, like the work exploded technically, and we had this really a showstopper for before we introduced the Besium, and we had like a developer, two developers technically, a developer and principal that were working on this to really put this to production, and like in 3-4 months, like they made it. But it's really tense because the product in our team was constantly asking these things because he wanted to make sure why are we doing all such implementations, because it's not visible to our customers, but it's visible to us because we don't have this coupled system right now. It's really easy to add new features, and it's not tightly coupled as it was from the front end to the back end. I was mainly talking about here on the back end technologies, but on the front end was really interesting. We took, I think 1 year like to decouple all our front end services with the outside from the monolith.
Right? Is that an invitation for Milos next year to present the front end side? No. Okay.
We will have probably Vladan presenting my front end side.
Okay,
So.
perfect. Good to know. Do you guys have any additional questions? Okay, I need help with this one.
So I remembered when you started with a project like a while ago using Keycloak. So were there any regrets of using Keycloak as EM, or like did you consider any other like a scaled AWS like Cognito?
Yeah.
In the
Cognito
meanwhile, was that decision that like we heard this story about like problems that you faced just because you now this decision is made, and tell us a bit like what changed in the meanwhile.
Yeah, good question. So yeah, the Cognito was one of the other implementations that was considered, but it was a little bit of, I would say, expensive for us in that point, and we will not, because we have our own Kubernetes cluster, we were not able like to fit in so easily. And with Cognito, it's a little bit hard like to have this kind of extensibility. I would say it's harder. It's not like something you cannot do, but it's harder. But then we went from to Keycloak, and Yeah, until the load was there, it was everything was great. But when the load started, the issues with with infinite span cache started to popping up, and it really like was giving us a lot of headaches during these years. And but yeah, luckily for us, we have an amazing DevOps team. They really put some fantastic things on production because they implemented blue-green deployment of Keycloak, which really helped us a lot and save us. And not just that, it really allows us to sleep nice, because if there was no implementation of that, we'll probably not be sleeping for so much of the time. So it's not a perfect solution. It was also to state that we started with version 9, from version 12, from 12 to 18.
It's not easy to upgrade, right?
Yes,
And
especially from 12 to 18, because the principal engineer took like one year like to migrate everything to the version of 18, because it was using Quarkus. It then at the beginning it was deployed on JBus, and so it used Firefly, and then the Keycloak switched to Quarkus, which technically was a better solution, but you could not like see any kind of benefits either in the speed or anything. So we are really maybe excited about the new versions, because we have a plan to jump to the new versions and maybe jump to the latest version of Java, but we'll see.
okay, yeah, thanks.
Thank you.
Okay, wrap it up. Thank you,
Another
Petko.
question. One question more, please.
Sorry. Oh, it's hard to.
Sorry, I know I'm not supposed to talk about AI, but how much do you think that AI and general related projects influence the need for microservices while you were transitioning?
Well, it often helps developers to write some code that is better than theirs at that point, or like if somebody does not have full consultation, and a lot of help we have from AI by writing unit tests, I will say, especially from the front ends. I personally don't use AI for tests, because it's not the way how I envisioned, but you can use it for this migration to the microservices. Yeah, it was really like tied it up so that no AI, like you cannot like provide so much of the details to AI, so it will state you that the perfect architecture or the perfect solution. But for other things, you can like ask the AI what does it think about some specific architecture, and you will probably get some of the answers that will guide you through. It will not be the best possible answers, but it will help you a little bit. Like it, then at the end, you as an architecture, like you need to figure it out. So, but you have help, and it will help you a lot, especially with some small tweaks and small configurations. With small tweaks on either on Kafka consumers, you can get a lot. Hope that answers your question, maybe half of it. Yeah.
Thank you, Petko.
Thank
It
you.
was a cute presentation.
Nice.
Well done.
Yeah. So thank you, Mitza, for having this nice event and helping us out on the presentations.
Very
So thank you.
welcome. I'm not very surprised, because I was the one combining all the slides for the final presentation, but still it's nice. Thank you very much.